we'll get the awkwardness out of the way. All right. So, Maddie, this is where YouTube Nation can hear anything that you say, because I get a lot of views. I probably like 5 views for each video. Any crazy teacher from yes, yes. No, not another one. So, who do you want to say hi to from first hour that could be watching?
Kenzie Waldemar.
Okay, so I'll say hi, Kenzie. That's how we say that in America. That's what we say. Try it.
Hi, Kenzie.
Kenzie, you don't watch videos anyway, so what does it matter? All right. So you ain't gonna see this. Tell you what. First person that from first hour that can tell me that they watched this video, send me an email saying that you watched my video. First person, you get a free candy bar. How's that? What do you think it will be? Dibs on who? Who do you think it's gonna be? Riley? Daniel? How about Sarah? Sarah Niebuhr. I think Sarah would probably be. My dibs are on Sarah. I think she'll be the one. But we'll see. Oh well. Free candy bar to one of you guys. It won't be Ashton. Will not be Ashton. Alright. Okay. We believe in you all. You're probably all watching it together. You're probably asking to be dismissed from choir just so you can watch the math video. That's my thought. Okay, well, let's go to work. We are going to continue to find solutions. We have 3 different types of problems that we're going to work on. And the first one is examples with different theta values. So what do you notice is different about these 2 problems compared to the ones we saw the other day? Yeah, here you got 2/3 theta, and here you got 3 theta. So that changes the problem. As opposed to just having theta in there, we have a constant on the theta value. And that's going to change our approach just a little bit. We start solving this problem just the same as we did before by subtracting 2. So 4 sine of theta, of 2/3 theta, excuse me, is equal to -2. Divide by 4, so sine of 2/3 theta is equal to -1/2. Now, this is kind of the tricky part here, okay? In order to solve for theta, what has to move? And the sine. So we got to get rid of the sine and the 2/3. Which one do you think you get rid of first? Got to get rid of the sine. Before we can get to the 2/3, you got to get rid of sine. How do you get rid of the sine? Inverse. So at this point, we have to inverse. And so I'm going to set up my quadrants. Where is sine negative? Yeah, 3 and 4. So I'm going to sine inverse 1/2. Sine inverse 0.5, and I get, you know this value, 30 degrees. And look at your result. You have 150, I'm sorry, 210. Or, what's the other one? 330. So you got 2/3 of theta is equal to 210, or 2/3 of theta is equal to 330. So we still haven't got rid of that 2/3. Now I could get rid of the 2/3, right? Multiply by 3/2, right? So 210 times 3 divided by 2. Is my answer between 0 and 360? Nope. I'll do the other one. 330 times 3 divided by 2. 495. Is that between 0 and 360? So we came up with a solution that's outside of 360, so technically we would not include it. That's our only solution that exists between 0 and 360. Now, I'll give you just a little hint ahead of time, okay? 2/3 theta. If you multiply the 360 by, that 3/2, 360 times 3 divided by 2, or I'm sorry, 2/3, excuse me. 360 times that 2 divided by 3, you get 240. So we came out with one angle that was less than 240, right? So you could have seen right away that 330 wasn't going to be the one that would work, because 2/3 of 360 is 240, so it kind of gave us an indication ahead of time. So we're going to do the same thing over here. This one, instead of a number less than 1, we have a number bigger than 1, okay? That's really going to change it. You remember from yesterday how we would solve this? If you divide both sides by a cosine, you're going to lose solutions. So we subtract and factor. 2 cosine squared of 3 theta minus cosine of 3 theta is equal to 0. Factor out a cosine. Cosine of 3 theta times 2 cosine of 3 theta minus what? 1 is equal to 0. So we have two problems here. We got cosine of 3 theta is equal to 0, and we have 2 cosine of 3 theta minus 1 is equal to 0. Solve this one over here, you get cosine of 3 theta is equal to 1/2. Where's cosine equal to 0? (180) it's equal to -1. Where's cosine equal to 0? 90 and 270. 90 and 270. Watch what happens. Three theta equals 90. Okay. Divide by 3. What do you get? 30. Three theta equals 270. Divide by 3 and you get theta is equal to? Are those between 0 and 360? I think there might be more that would be between 0 and 360. Yeah. Watch, for example. If you plug in 90 and multiply it by 3, you get the 270. I bet that if we plug in another value that we would multiply by 3, we could still solve this. Watch what happens here. As you got your angles, you said 90 and 270. I'm going to draw this out, okay? So 90 worked. 270 worked. What else do you think is going to work? Back up to that spot. That spot will work too. That's 90 plus 360, which is 450. Try it. 3 theta equals 450. Divide by 3 and you get? What's 450 divided by 3? 150. Is that still between 0 and 360? Yeah, it is. Let's continue to go around. If I go back to that spot again down there, so that's 180 degrees past 450, 630. So 3 theta equals 630 degrees. So theta is 210. Are you still between 0 and 360? Yeah. So let's go around again. Or are you tired of it? Do you understand now that you could get more than a lot of solutions in this scenario? Okay. We don't have enough time between now and the end of this course to get into all the intricacies of some of these problems. I just want you to see that you could come up with a lot of solutions, couldn't you? Your book will list them all. For the purpose of this class right now in this test, as we've lost a lot of days for snow days and other situations, we'll refine our answers to simply, when we get multiple angles like this, or I'm sorry, when we have a different angle in front. In this situation, you've got to just list the one. You got to understand 315 works and 495 doesn't. In this situation, go ahead and just take the two smallest ones, okay? And we'll just stop there. We could come up with a lot more. We're not going to, okay? So let's cosine inverse this side. What's cosine inverse of 1/2? 60. Very good. So we'll draw our quadrant just like we did before. We have 60 degrees. Cosine is positive in the first quadrant and the fourth. So we have 60 and we have 60. So when we cosine inverse, we end up with 3 theta is equal to, what's my first angle? 60 degrees. And then 3 theta equals, what's my second angle? 300. So if 3 theta is equal to 60, then theta is equal to 20. And if 3 theta is equal to 300, then theta is equal to 100. So the values I'm concerned about are 30, 90, 20, and 100. Those are the values I want to know. Okay? I'm not, obviously there's a lot more that exists between 0 and 360. I'm not going to labor us by trying to find them. Is that okay? So, that's the important part. You got to remember, if you have a number in front there, first inverse sine or inverse cosine, then get rid of your 2/3 or your 3, whatever it would be. Okay? All right. These two are actually a little bit easier. These involve examples of converting to a different trig function. So what do you notice is different about problem 3 compared to anything we've seen before? Okay, the negative square root, we can deal with that. Oh, she said to say hi to Kenzie on the video because she thought you were gone, but now you're here. Okay, so did you want to say hi to anybody that's gone today? Who?
Lindsay. Hi, Lindsay.
Just hi? Oh, she misses you. Okay, that's great. Oh, don't we feel so loving today? All right. Wonderful. All right. Well, you guys are right. We got the negative square root, but there's something much more glaring here that makes this problem different. You got a cosine and a sine. We haven't had a problem before. We got 2 of them. Yeah. Kenzie needs a paper. So what we're going to do is there's a little trick here. I told you don't divide off a cosine earlier. Well, in this situation, if we divide a cosine from both sides, we are not dividing off the cosine. We're simply renaming the sine function. We end up with the negative root of 3 is equal to what sine over cosine? Tangent. So we've rewritten a formula to be negative, or rewritten the equation to be negative root of 3 is equal to tangent of x. Well, we can solve that, can't we? Yeah, that's no big deal. We just draw our quadrants now. Which quadrant says tangent negative? Second and fourth. Take out my calculator. Tangent inverse of the root of 3. And I get 60 degrees. So I got x is equal to 120 and 300. That wasn't too bad, was it? You see the trick, though? That's the important part. Gotta see that trick. All right, try the next one then. Here I got cosecant and I got 2 sine. Well, let's see what happens if we divide both sides by cosecant of x over 2. What's cosecant of x over 2 divided by cosecant of x over 2? 1 equals, watch how I'm going to write this, 2 sine of x over 2 over 1 divided by, and cosecant can be rewritten as what? 1 over sine. So I'm going to have 1 over sine of x over 2. So if I want to simplify that, I multiply by the reciprocal times sine of x over 2 over 1. And you get 1 is equal to, I have 2 times sine, what? Yep, sine squared. Sine squared of x over 2. So that's what I need to solve for now. So I've renamed the equation to look like that. What do I gotta get rid of first? I got 3 things. I gotta get rid of 3 2's. Which one do you get rid of first? Yeah, the one on the outside. So get rid of 2, divide by 2. A half is equal to sine squared of x over 2. Now what? Do you get rid of the squared or do you get rid of the x over 2 part? Ooh, we got square root. Plus or minus the root of 1/2 is equal to sine of x over 2. Where is sine positive? Where is sine negative? Positive in the first, second, negative in the third, and the fourth. Let's give it a shot. Sine inverse of square root 1 over 2. If you didn't see it already, the answer is going to be 45. You have 4 angles, 45 degrees. When I sine inverse, what was I left with? X over 2. So x over 2 is equal to, x over 2 is equal to, x over 2 is equal to, and x over 2 is equal to. So, that's the first one, x over 2 is equal to 45. Then, 135. 225, 315. How do you solve each for x? What do you do? Multiply by 2. So we get x is 90. X is 270. X is 450. And x is 630. Are all those between 0 and 360? No. So those are ones we keep. Not too bad, a little bit more tricky, right? All right. These last 2 are the toughest. Are you ready? Here we go. What's different about number 5? It's got a sine and a cosine. We've seen that. Okay, they're on the same side. We can move it over, get sine 2x is equal to cosine of x. They don't have the same angle, do they? One's got a 2x, one's got an x. That's a huge problem. We can't do it. Unless we could come up with a substitution. Do you remember from the test you just took what sine of 2x is equal to? from your sheet. If you look on your trig notes, I'll pull it up if you want to take it out because you're going to want to use this. This is the most comprehensive sheet that I gave you, so we'll look at this one. Go gadget, smartboard. There we go. All right, so at this point, you pull out your sheet and you start looking for a sine of 2x or a sine of 2a, and you find it under your double angle formulas right here. Whoop. And this is what you want to grab. Sine of 2x is equal to 2 sine of x cosine of x. Well, maybe that will help us out. Maybe it won't. But we're going to give it a shot. So I go back to my sheet and I try plugging in 2 sine of x times the cosine of x minus cosine of x is equal to 0. Well, does that allow for me to solve it? Maybe, maybe not. What could you try? Does anybody see the next step here? Saw it yesterday. Factor out a cosine. Very good. Cosine of x times 2 sine of x minus 1 equal to 0. So we have two equations. Cosine of x equals 0 and 2 sine of x minus 1 equals 0, which can be simplified to sine of x is equal to 1/2. Where's cosine of x equal to 0? 90 and 270. Good, we've already said that once. Sine of x is equal to 1/2. Where is it positive? First and second. Draw my angles. Sine inverse 1/2. We've done that 3 times a day, I think. 30 degrees, 30 degrees. So x is going to be 30 degrees and 150. I think your book puts all the answers in radians. So, sorry. Still a lot easier for teaching purposes to work within degrees. Well, that wasn't too bad, was it? Sometimes, you know, the trick is you got to seize the substitution, then you got to see you got to factor. I mean, if you could get these 2 steps, then you're probably golden. If you can't get those, then you're stuck and you can't figure out what's going on. All right, so we try number 6. They're both x. But now you got a +1 as well. You can't just divide. So if you divide through by cosine, yeah, you get a tangent over here, but then you get a 1 over cosine. That doesn't help me at all. Isn't it nice when you have something squared that you can then make a substitution? You know, we know that our sheet has a lot of things where if you square something, you can substitute something in. Here's the problem. Okay, watch this basic problem. X equals 3. How many solutions are there? 1. Square both sides. X squared equals 9. How many solutions are there? 2. Positive 3 or negative 3. When you square both sides, sometimes you add a solution that does not exist. It's called an extraneous solution. So if we do that, it's like, yay, we can find something. But there's also a bad side. We're like, okay, we just increased the power of it, and that's going to add solutions that aren't there. So we're going to have to plug our solutions back in the end. Anytime you square both sides, you say, gotta make sure we plug in at the end to make sure that we can see if we added solutions or not. So that's the risk we run. But we're mathematicians, and we can handle stuff like that. So we go about our business. Square this out. We get cosine squared of x. What's going to be in the middle? If this was x plus 1 quantity squared, it would be x squared plus 2x plus 1, right? So this is cosine plus 1 quantity squared, so what do you get in the middle here? Yep, 2 cosines. Now, people watching video right now are saying, well, that doesn't look any better than what we started with. It doesn't if you don't see this. Right? Can't you substitute 1 minus cosine squared in for sine squared? That's a valid substitution. We've done that 20 or 30 times over the past couple weeks, right? Then everything will be written in terms of cosine. And if everything's written in terms of cosine, then we can solve. So that's how we got around our problem at the beginning of how we didn't have sine or cosine matching up. We squared both so we could then make a substitution. We run the risk of adding solutions. We'll check our answers at the end. Cosine squared of x plus 2 cosine of x plus 1 is equal to 1 minus cosine squared of x. What do you subtract from both sides? 1. That goes away. Add the cosine squared. We get 2 cosine squared of x plus 2 cosine. 2 cosine of x is equal to 0 then. How do you solve that? Factor out a 2 cosine. 2 cosine of x times cosine of x plus 1 is equal to 0. Where does 2 cosine of x equal to 0? Divide both sides by 2. Cosine of x is equal to 0. We've already said this a few times. Where's cosine equal to 0? $90 and 270. And then we got this cosine of x plus 1 equals 0. Where is cosine of x equal to negative 1? 180. We got 3 answers. Anybody want to guess which ones stay and which ones go? All right. Let's plug them in. We got to see which ones work. Let's try 90. What's the cosine of 90? 0 plus 1? 1. Sine of 90? 1. So did that work? Yeah. 90 works. Let's try 270. Cosine of 270 is 0. 0 plus 1? 1. Sine of 270. Negative 1. So did that work? No. Try 180. Cosine of 180. 0. Or yeah, negative 1. Negative 1 plus 1 is 0. Sine of 180? 0. So 180 worked, 90 worked, 270 did not. Those are our solutions. So we created an extra one, we just plugged in and tried to find out which one worked, which one didn't. That's it. Not too bad, huh? You know, instead of teaching 4th hour, maybe we'll just play the video. Alright? I've earned a day off, haven't I, Kenzie? Putting up with you guys every day. It's hard work. Alright. Let me get your assignment. So, students watching, there's your assignment, and some of those problems are going to be hard for you, and that's okay. I would say there's 8 up there. You should for sure be able to do 4 of them. So our plan is to hopefully do a review day on Monday, an activity, study guide on Tuesday, and then a quiz on this on Wednesday. I know you guys are gone. We'll figure something out. Have a good day. Hope you guys are having fun. We'll stop right at 30 minutes. How's that?